Hey everybody, welcome to our Microsoft Teams Readiness training. My name is Nishant Nataraja. Today's session is the second part of a two-part course that will introduce you to and help you deploy and operate Microsoft Teams. Just as a quick training disclaimer before we begin, this training is a snapshot of the product as of the March 2017 GA release. Please always refer to the latest version of this training at aka.ms/Microsoft-Teams-deployment. In our last training, we covered the introduction to Microsoft Teams. It's where you get to look at the features and what they can do. We've covered the scenarios for chat, document collaboration, meetings, tabs, bots, and connectors. I'd like to remind everyone that if you haven't already done so, please visit the first training. The trainings do build upon each other, and the concepts we speak to are very interrelated. But just as a refresher, let's recap the UI really quickly before moving on. On the far left side of the application, you'll see the icons that will navigate to activity, chat, teams, meetings, and files. We currently have a view of the Teams page. You can see your teams and favorited channels underneath the global search bar. In the main UI, we have tabs across the top and our threaded conversations below. We have a packed agenda today. The topics we'll be covering are the foundation that Microsoft Teams is built on top of, infrastructure and network planning guidance to ensure you can conduct successful meetings, the admin portal settings to manage users and features, what are the options for client rollout, and finally, security and compliance features that are built into Microsoft Teams. By the end of this training, we want you to be able to understand that your firewalls need to be configured to allow access to the backend services. Your network performance will impact meeting quality, and the clients will stay up to date on their own. This training has been updated since preview. If you have viewed this training before, you should pay attention to the small updated banner in the top right corner. This will give you cues on what has been updated since the preview version of this training. We've introduced this practical guidance in the last training, but here's a recap. We've created a document that provides in step-by-step detail the key decision points you will have while trying to plan, deliver, and operate Microsoft Teams. There is an interactive planning workshop that helps you start the conversation on how your organization can start leveraging Microsoft Teams. We also provide you with a bandwidth calculator. This will help you assess your bandwidth needs when using Teams. This content can be found at successwithteams.com. Let's begin with the foundation of Microsoft Teams. For Microsoft Teams to become the hub of your team's collaboration, we had to leverage and incorporate many of the existing Microsoft products you use. In this section, we'll take a quick look at how we reach across many of our Office 365 products to build Microsoft Teams and fit it into the Office 365 collaboration portfolio. Microsoft Teams uses Office 365 groups to manage memberships and access controls to the conversations and assets within your team. Owners of an existing Office 365 group can move them over to Microsoft Teams. Team creation settings are controlled through the admin portal, where you already control group creation settings. Microsoft Teams leverages Azure Active Directory to use your existing corporate credentials to allow you to sign in without having to create a new account. Your identities are stored in Azure Active Directory, and Microsoft Teams can leverage AAD Modern Authentication for enhanced security. A group mailbox and calendar gets created for every team. Also, regardless of where the meeting is created, the meeting itself is stored in Exchange and will be accessible from both the Microsoft Teams client and Outlook. Each team will get a SharePoint site provisioned, with the permissions governed by the group's membership. Each channel in a team will get a folder on the SharePoint. Any uploaded file during conversations in channels get uploaded to the SharePoint site. Files that are shared during private chat are hosted on the sender's OneDrive for Business storage. Navigating to the Files icon on the left side of your application gives you instant access to your OneDrive for Business files. As you know, Microsoft Teams is a service-powered client. So let's jump into what it'll take to get the client to successfully communicate with the backend services. Customers will need to whitelist a new set of endpoints on their proxies and firewalls. aka.ms/teams-ips-ports has a complete list of endpoints to whitelist, and be sure to subscribe to the RSS feed and stay up to date with any changes. We are only showing a small snippet of this page. It is very important you whitelist all the endpoints and ports on this page to ensure the client can successfully communicate with the backend services and behave as intended. We don't recommend you use a proxy server, but if you need to use one, it will need to be able to resolve public DNS records of the Microsoft Teams service, and it will need to allow direct UDP-based routing and traffic. As everyone here probably already knows, network planning is crucial to any chat and real-time communication client. We'll be referring to chat service and real-time media a lot during this session, so it's probably a good time to define what these mean. Chat service powers anything that can be delivered not immediately, but has to be a complete message. We shouldn't be losing any pieces of information along the way. Real-time media is any type of communication that happens instantly between team members. Here we can afford to lose some packets here and there without losing the overall experience of the conversation. I'd just like to give a quick disclaimer on our network planning session. Even though we'll mainly be speaking towards network usage and planning around meetings in this session, it is only a small portion of where users will end up spending their time. Most teams will spend their time leveraging chat services. To begin network planning, we'll need to understand how the client communicates with the service and other clients. Anything that is not real-time media will always be traveling through the chat service in Office 365. This is how we ensure your data and chat is persistent and that it is accessible and can be continued from any device at any time. It is also how we ensure your data is stored in the correct regional data centers. Real-time media works slightly different based on the scenario. If you're in a private chat with only two people, then your audio, video, and screen sharing will try to go as direct as possible between the two people. Now, any meeting in a channel or private chats of three or more people will send both chat and media to the service, where it'll get redistributed to the other clients. This was just an overview. We'll double click on the call flows in a few slides from now. Let's break it down by individual component of real-time media. We'll start with audio, which is fairly straightforward. Anyone who is speaking will send up their audio stream to the conferencing unit. The unit will mix the streams, then redistribute a new single stream to all participants. Now for video, everyone will send up their video to the conferencing unit, and everyone will receive at most 4 video streams of the 4 most recent speakers. During screen sharing, only one person will be uploading a stream. The conferencing unit will redistribute the stream to all participants. Here we have a one-on-one private chat call flow. We have Alice and Bob both signed into their Teams client. You see that the client will always send the chat content via the chat service in Office 365. Since this is text, pictures, and files, we can tolerate some network latency. Here, each client uses port 443 to send the information to the chat service. For audio, video, and desktop sharing, however, we want all traffic to be as direct as possible. We leverage a protocol called ICE to find the most optimal media path. In this case, a direct connection is possible. That means both clients are able to communicate directly to each other. For example, two clients can directly talk to each other if they both have public IPs or both are on the same internal network. This is great because latency is as minimal as possible, and within your internal network, media does not go over the internet. For those who are interested, we leverage protocols called ICE, Stun, and Turn. We won't be talking too much to these protocols in this session. In this example, Alice and Bob are still trying to have a private conversation, but they're on different networks. The chat content still directly goes to the chat service. This way they can exchange private chats and also contribute to the same channels. As you see, the firewall between them is not a problem. However, if they want to start a conversation in a real-time workload, they'll run into a problem. As you see, direct connections are blocked. This could be a company firewall or a firewall specific to where Bob or Alice are. This is where we will use Office 365 as a media relay. Alice will establish a connection to Office 365, and Bob will also establish a connection to Office 365 for this particular session. The media relay will proxy any real-time media to the relay and relay it to the other user. The preferred protocol is UDP on the listed ports. We can fall back to TCP 443 if we have to. We'll talk about it in a later slide on why we prefer UDP. As you see, Alice and Bob can now still have a real-time conversation even though there is no direct connection between the users. This path is less optimal as all the traffic needs to travel to the relay first and then to the other user. This will impact latency and network path, but usually these delays should not exceed a few milliseconds. The important point here is that Bob and Alice will still be able to talk to each other. Let's take a look at meetings. In this example, Alice, Bob, and Charlie initiate a meeting. The path to the chat service remains the same, but real-time media is different. No matter how many users you have in a meeting, it will always be hosted in Office 365. Even if you have just 2 users, everyone will send their real-time media to the conferencing unit. The conferencing service, as described before, will mix the audio streams and send down only one to each user. It will also distribute the video and screen sharing streams to all participants. This means that each participant will establish a connection to Office 365 for real-time media on the same ports as the previous scenario. Let's go over a high-level overview of which behaviors of TCP and UDP affect our experience. For those who may not know, TCP and UDP are both protocols that are used to send packets over the internet. Both of them have many differences and both have their advantages. We want to concentrate here on reliability. TCP always requires that the receiver acknowledges every single packet. So if a packet is lost, it will be sent again. It is great for most cases, like if you send an email and you don't want any of the packets to be lost. But this also means that if a packet is lost, delays are introduced and we will need to wait for a retransmission of that packet. UDP, on the other hand, has more of a fire and forget approach. If a packet is lost, the sender will never know. For real-time communication, this is what we're looking for. We want to get packets from the sender to the receiver as quickly as possible, and if we lose a few packets on the way, we do lose some information. However, a single packet only has a very small piece of audio or video, and the codecs are fairly smart and can recreate the lost information from other packets, as long as you don't lose too many packets. If we do lose too much information in the packets though, you might experience a glitch, but we still prefer having the call continued instead of waiting for the resending of packets. If the UDP ports are blocked for some reason, let's say by a firewall outside of your control, Microsoft Teams will use TCP for real-time communication. However, every lost packet will result in an additional delay. If the delay becomes too large, the conversation will feel choppy. Hopefully that clears up why we want you to allow real-time communication over UDP. Make sure that your network allows clients to talk to Office 365 on the UDP ports listed, and ensure that traffic can bypass proxy servers. If you do send traffic through proxy servers, media might have to fall back to TCP. And as discussed, if there are any connection issues, the quality will be impacted. Real-time communication is different and difficult. It's very sensitive to packet loss, jitter, and latency. Your wireless network may be good enough for non-real-time workloads, like emails, downloading documents, or even watching video. In real-time communication, however, latency can degrade the experience. For access point coverage, be mindful of over and under provisioning. For example, a conference room will need more coverage as compared to a distributed working area. Work with your networking team on a site survey. Over the next few slides, we'll be going over the theoretical maximums in terms of throughput that you could see. Bandwidth usage and calculations are complex topics. We've stood up a section on our Practical Guidance website that has a great bandwidth calculator that will really help you assess your bandwidth needs when using Microsoft Teams. The next few slides take a deep dive on how these calculations work, but please visit aka.ms/bwcalc for the practical guidance and the most up-to-date information on bandwidth planning. We expect audio to be present on all meetings, regardless of video or screen sharing. For audio, we're showing a very conservative number at 100 kilobits per second. This will be the max in each direction. As we said before, the conferencing service will aggregate the inbound streams and push down a single stream to all the users. Just a reminder to our earlier disclaimer on how chat services will be used more than audio and audio will be used more than video. The next few slides will be required just to explain the layouts and bandwidth usages for video. Our first layout will show that during a two-person call that almost the entire screen of the client window is used for video. In all the layouts, the small square at the bottom right is your video that you'll be sending to other participants. When a third person is added, we split the screen down the middle. Once we have 4 participants, the primary speaker will have the largest video on the left and the other 2 members will get split on the right. Here we have a few more layouts, where you can see a 5-person conversation will give every person an equal quadrant. An important portion of collaboration is screen sharing. Notice that when only the screen is shared, we get a full screen video. And when everyone adds video, you can see the 4 videos next to your video at the bottom right. During screen sharing, you can pin the 4 active speaker gallery or the presentation. An important consideration is bandwidth planning. Let's break this table down, as is what we'll be using in the following few slides as well. Provided network conditions allow the throughput, we see here the max that meetings will require for a typical 1080p screen. The first column is the number of participants and the activity is typically just video, until we get to the bottom 2 rows where it's screen sharing and then video plus screen sharing. The second column indicates the maximum video stream resolution you can request from each sender. Remember, having your client using your full screen versus not will reduce these numbers significantly. Where we show multiple resolutions being pulled, it's because each section of the layout will only request what is needed to fill that portion of the screen. The third column shows the maximum megabits per second. The numbers are a sum of the total streams being pulled down. In the last row, we see this screen sharing plus video. Here, you can only pull down the last 4 active participants. One major point to note is that the throughput is data dependent, which means if there isn't much visual noise in the frame, you'll see much lower numbers. Also, if your network doesn't allow, the client will start reducing the requested resolution to improve the meeting experience. This chart is showing the max upload bitrate based on the number of participants and activity when everyone is using a 1080p monitor. During screen sharing, you can only be uploading or downloading a screen, unlike video chat where you could be doing both. So this is from the active presenter's view. Because the streams get uploaded to the conferencing service, you aren't uploading multiple streams of the same resolution. This chart represents numbers when the absolute worst combination of layouts and monitors occur. For this to realistically occur, you need to have someone in the meeting essentially requesting every variation of resolution. The participants on the meeting would need to have monitors ranging from an Ultra HD capable monitor to pull the 1080p full stream with 4 or more participants, but at the same time you need to have a participant who only has a 720p monitor to get this disparity in streams. And even if you do, the client and service will see if your network can handle it, and if it can't, it'll start consolidating the streams. This would be the absolute worst upload if the network permits. In full transparency, we just want to show you the theoretical max. So we've discussed what Microsoft Teams is built on, how it behaves, and how to configure your network. Now we need to learn how to manage Microsoft Teams for your tenant. In the Office 365 IT Admin portal, you can adjust tenant level settings in the Services and Add-ins section. All settings here will be set for the entire tenant. If you did enable Microsoft Teams at preview and save those changes, then disabled Microsoft Teams for your tenant, we will not re-enable it automatically for you at GA. This is a quick recap from the previous session. These are the subscriptions that Microsoft Teams will be available for at launch. You'll need to be a part of Business Essentials or Business Premium or Enterprise E1, E3, or E5. And customers who have an existing E4 subscription will also get Microsoft Teams. At launch, Microsoft Teams is enabled for all tenants by default. You can use PowerShell to disable Teams at a user level. We have more how-to guidance on this in our Teams Practical Guidance. Using PowerShell to modify tenant level settings for Microsoft Teams isn't supported. You'll need to use the UI for tenant settings management. This global switch to turn off Microsoft Teams is temporary and will be removed in the future. To manage individual user access to Microsoft Teams, use licenses. You can also directly access our practical guidance for Microsoft Teams from here. Once the toggle switch is on, the rest of the toggle switches will appear. In general settings, you can set if you want the organization chart to appear during one-on-one chats. This chart will allow users to look up the hierarchy of the person they're chatting with. Also, if you want to disable Skype for Business to Microsoft Teams Interop, you'll do that here. As Microsoft Teams leverages groups to manage membership and assign team ownership, you can directly navigate to the group's control panel to manage settings such as who is allowed to create teams. For team creation, we suggest you create it from within Microsoft Teams. Group creation must be enabled as a feature under Exchange so that groups can be created. Enabled is the default state for this setting. IT admins can control who can create groups by updating the MSOL settings with PowerShell, and to restrict it to a specific security group. The Calls and Meetings section lets you choose if your users will be allowed to schedule private or channel meetings, and use video or screen sharing during any types of meetings. This is great for those who are concerned with privacy and security. Some organizations may also wish to leverage these settings to reduce the amount of network traffic on their infrastructure. Microsoft Teams does use video-based screen sharing, which is able to even work well in low bandwidth networks. As a tenant admin, you'll be able to enable or disable media content such as GIFs, customizable memes, and stickers, with the toggle switches in that respective order. When GIFs are enabled, you can apply a content rating to restrict the type of GIFs that are allowed within Microsoft Teams. Content ratings include the following: strict, moderate, and no restriction. It is recommended that you choose a strict or moderate setting for your organization. Team owners can only further restrict the content rating setting. In the Bots and Tabs section is where you control the extensibility of Microsoft Teams. The first setting is to allow you to use bots and tabs within Microsoft Teams. Disabling this setting will not disable Tbot, as it is a part of the product's help system. The second setting will allow your developers to sideload your proprietary bots and tabs. This would help them greatly when using the bot and tab development frameworks. And finally, email integration setting will allow users to fetch a channel's email address and send emails to that channel. Now that you've enabled Microsoft Teams for your tenant, we'll need to distribute it throughout your organization. We support a variety of clients. The web client will perform a browser version detection upon connecting to teams.microsoft.com. Unsupported versions of browsers will then be blocked and will recommend a user to download the desktop client or mobile app. Most of the functionality is available in the web client, but meetings and calling will be available in the desktop client. Clicking on the meeting link without a client will prompt a call to action to download the client. You can fetch the Windows and Mac packages from teams.microsoft.com/downloads. The current Windows package is an executable, and the Mac client is a DMG that is downloaded and installed on the local machine. If your users do not have installation privileges, then you can distribute them through your existing distribution channels. Mobile applications are published in their respective app stores. The Microsoft Teams client cannot be sideloaded or distributed through MDM. Teams now supports conditional access policy to be enforced via Intune. Our web and desktop clients will auto-update. Mobile applications will go through their App Store policies. We have spoken to what features are enabled by the chat services in our first presentation, Introduction to Microsoft Teams. During this section, we want to speak to some technical details of security and compliance for these services. All of your data is encrypted at rest and in transit. The data that is stored at rest will be in the regional clouds based on the tenant location set in Azure Active Directory. Chats are managed in the Microsoft Teams chat service, which runs within the O365 compliance boundary, but it is separate from Exchange or SharePoint. Microsoft Teams was architected with compliance, authentication, and privacy in mind. Microsoft Teams is Tier C compliant. It involves implementing a bunch of industry standards. The details of these standards are outside of the scope of this training, but you can read more at aka.ms/O365-compliance-doc. Basically, what it all means is that Microsoft Teams protects your data securely by using strong security measures, which includes two-factor authentication, hard passwords, and access policies. Your data is always encrypted, whether it is chat, notes, or files. It's your data, you own it, you control it. Like all Office 365 services, Microsoft Teams offers a bunch of compliance features. Of course, these features are still based on the SKU of the license you own. We have some great guidance in our Microsoft Teams practical guidance that highlights what these items mean and what kinds of licensing is required. Microsoft Teams is a service-powered client, which means there is very little debugging that can be done from the client side. So before investing time into troubleshooting and opening a ticket with support, check the admin portal to see if there are any service outages for Microsoft Teams. We have seen that most issues are connectivity issues. Please do double check that the required endpoints at aka.ms/teams-ips-ports are whitelisted. Finally, if neither of these steps resolve your issues, you'll need to collect the debug logs and open a support ticket. You'll only get debug logs from web and desktop clients. In our Microsoft Teams practical guidance, we outline additional types of logs that can be requested by support for further investigation and where they reside on your machine. We've gathered the resources we've discussed during this session for you. We've even added a few things we didn't speak to, but thought would be useful. Here are the download links for all of our clients. As discussed, all of our desktop clients can be found at teams.microsoft.com/downloads. All of our mobile clients can be found in their respective app stores. These reference items will help you get you on your way. The first link is to this two-part course. Next, we have compiled a written guide that you can use to manage tenant settings. Below that, we've included a link to an FAQ around Microsoft Teams. Finally, the list of URLs that you need to whitelist to enable Microsoft Teams, with the link to the RSS feed below. If you'd like to learn more on the development around tabs, check out our Microsoft Teams tabs platform, guidance to design a tab in Microsoft Teams, and sample tabs. If you'd like to learn more on the development around connectors, check out our Office connectors in Microsoft Teams and view what connectors we already have available. If you would like to learn more on development around bots, there are some great resources for you to learn about bots in Microsoft Teams and learn about the bot framework. Here are some great product videos that have been put together to highlight some key scenarios of Microsoft Teams. They are also a great reference point on how to use the product. And finally, don't be shy to jump into our Microsoft Teams community and continue the conversation with us. I'd like to thank everyone who watched for your attention, and we hope you love the product.